and Enterprise Works, Chicago, as a strategy consultant for academic innovations. So he has co-authored multiple journal articles, book chapters, and is co-inventor of 2 US patents. Excellent. So we are really having two, I would say, two scientists. So no, we are very happy to have you all. And today, no, just to once again, it give you some technical points. This is an online webinar. So any questions, you can just put it over the chat window. I'll pick up few questions and I'll make sure our speakers answer in the end after their presentations. And in case if there are more deeper technical questions, we will route those questions to them through email and then later let them respond to you. We will get coordinates of both of them for all of you to write to. And again, this being a technology based learning, we hope there is no technical glitch, but in between, if there is any technical glitch, as a first option as an attendee, you'll have to just click on the reconnect button at the top. If there is a loss of audio, loss of video, just by clicking on the reconnect, it will connect in next 2 to 3 seconds. So you will not miss much. In case if there is a little larger delay, etc., don't worry about it. The full session is being recorded. It will come to you just after the season. You can always go back and learn that. So ICT Academy is very proud to have both of you, and thank you very much Anand Geeta Govindan of MathWorks and Saravanan from our team who have worked together to put this particular session on today. So with this, let me move on to one of the speakers who will start the presentation. So you decide who will start and you can open up the presentation. Over to you, sir and ma'am.
Sure. Thank you so much, sir. Thanks for hosting us. It is a pleasure to address the ICT Academy through this webinar. And it's great to be part of that. I'll share the screen. Is the presentation visible?
Yes, Shamik, it is visible.
Let's go.
Shavik, you're not audible. Sorry.
Hello, audible?
Yeah, you're audible now.
Sure. Okay, sorry about that. So we'll talk about experiential learning in engineering and how that can help in engineering in different forms. So that will be our focus. So as sir already mentioned during the introduction, so both of us work in the academic group in MathWorks, Spandana and I. So we work with educators, academicians, research scholars, faculties on curriculum and different research projects using different parts of MATLAB Simulink in different forms. And I mean, we are part of this group called Customer Success Engineers, specifically for education. So our group essentially is, and we have like different people from different backgrounds. So since I'm from mechanical, Spandan is from chemical. Similarly, we have people from electronics, electrical, and then we talk with ourselves as well. And then we have a group who works with industries who are called application engineers. So we work with them also to get a flavor of how we use this in industry. So in that way, we can have basically projects which will be helpful for the industries. And that's also one of our focus areas. Specifically, our team works in making curriculum more interactive, which we will try to focus on in this session. And also research projects. So basically, there are multiple different research projects. So how we can kind of make them smoother, make them faster, and easier at this point of time. So that's one, I mean, basically our focus area. So we work with faculties throughout the country. I'm based in Delhi and Spandan is based in Bangalore. Currently we both are at home, but that's where we are based at, our offices at, and then that's our kind of the geography focus. And then we have people in different parts of the country as well. In terms of the company, just a brief overview. So currently, as you can see here, that we have like offices throughout the globe. The headquarters is in North America, Boston, and then which is basically in this region. And then there is the offices in Europe, Asia. In India, we have 4 offices: Delhi, Hyderabad, Pune, and Bangalore. And then we have around close to 5,000 staff as of now, and revenue as more or less as 1.2 billion plus. There are multiple users. Most of the users are from academia, as you all know, and then industries also use a lot in terms of application in different terms of industries. In terms of industries, if we talk about, there are people in all these sectors. Aerospace and defense and automotive are the biggest in terms of both revenue and usage. So if you think of any aircrafts like A380, Airbus, Boeing, so they are use it. There's something called model based design, where basically we can design everything of an engineering product in one platform, and that's one of the focus in any of these aerospace, defense, or automotive applications. Starting from that, if we think of engineering anywhere, there are any engineering products that can be used, be it like energy production, electrical, electronics, communications. It can be any machinery, robotics. So all those areas, as long as there is something we can simulate, and that is where it goes in terms of a simulation, in MATLAB Simulink. In terms of MATLAB Simulink, basically we'll talk about what those are. And then those are in terms of the end application of industries, but also we have, like, if you think of domain, if you think of something like deep learning or data analytics, today's world, that is not restricted to like computer scientists were using this like say 30 years back, but now like people from every disciplines use deep learning, machine learning, and that is one of the key thrust areas. Like if we think deep learning or machine learning to be like a tool as say mathematics, then how do we use for engineering problems? And then comes use of MATLAB Simulink, which is primarily for engineers and scientists, how we can use these advanced tools at the end for all of these type of problems, which can be deep learning, which can be Internet of Things, which can be like motor power control, or any of these which are mentioned here. Because if you think of an end-to-end product, like a final product, all these things club together at the end of the day. We have control systems clubbed with signal processing, robotics, whenever we think of a final product. So that interdisciplinary area is easier to model, because we support all these type of disciplines. In terms of, as many of you know, MathWorks is a parent company, and then there are two core products, MATLAB and Simulink. So MATLAB is more of a scripting language, but there are also apps which we'll talk about towards the end. So MATLAB means Matrix Laboratory, because matrix are the basic core of these things. And Simulink is more of a block diagram based approach. If you look into the figures here, so the top right one is more of a MATLAB platform, the bottom left one is more of a Simulink platform, where we have a graphical approach. So we use block diagrams. So the car is shown here. So if you think of all the parts of the car, engine, then the battery, if there's an electric car, the throttle, brake, all of those we can have models as a block and then combine them to make a virtual car in the Simulink environment. So that's Simulink. And MATLAB is more of the scripting language, where we write things, where we visualize. It's good for statisticals, machine learning tools, deep learning, all those different types of environment. So this is about what we are. Now we'll talk about how we support this industry academia ecosystem, and then we'll come to how we use for something called experiential learning. So if you think of the people involved, or the stakeholders, if you call it, in the industry academia, so there are research universities, there are universities, and there is academic colleges which provides undergraduate education. So all of them have their own focus areas. So research universities, they do either basic research or applicative research. They're more in the starting phase of an innovation, and then industry use that research and also use skill from undergraduate education. So all of these flows with each other, all of these people talk with each other. So if it has an undergraduate education, that might need to be used, sorry about that. So that needs to be used for research universities, and also for undergraduate education and industry. So that's how all these things club together. And MATLAB, we try to support all these environment, all these stakeholders here, because if they use the same platform, it becomes easier for knowledge transfer. That's essentially the goal here. Now, if we think about where we are in terms of this ecosystem, so in this industry academia ecosystem, so typically what happens is people graduate from high schools, they go to colleges, and they graduate from colleges, go for industries or higher research. So if we take 500 colleges, so taking the number to 11,000. So this right figure shows the orange is the intake in AIs in these colleges. The green curve, the green bars are basically for enrollment. Black ones are the student passed. and blue ones are placement. So the number of intakes are almost double in terms of as compared to enrollment. So enrollment have so people going for other fields. The green and black ones are more or less similar, so people graduate more or less evenly. And then we see a sharp fall in this blue bar here, which is basically placement. So there is around 50% drop from graduate to placement. So that lets us ponder why that is happening, how we can bridge this gap so that people get placed in a more smoother way, so to say. So if we talk with industries, or if we talk with what the system is like, we figured out that there is something that we can influence the undergraduate education with, so that people become more equipped to getting jobs just after fresh out of colleges. And also that helps in the research curriculum as well, because I mean, essentially that leads to more research and people can go for higher studies as well. So all these experiences basically help them to get jobs at the end of the day. So if we think about this education platform, then what we realized is if we do this classroom blackboard type teaching only, there are situations when, if you, this is like kind of a comic thing. So if you look into this this guy here with the yellow, this what he is thinking, he's saying, I ever need to know this when the faculty is teaching through the blackboard, because they lose interest. And when they lose interest, the fact that happens is they do not remember something once they graduate. It just becomes a one-time thing. They need to pass the exam. So just because if the faculty says that it is important, or if attendance is compulsory to attend the class, and if students attend that class, that does not kind of serve the greater good in terms of helping them know this thing for a longer time, have that in the memory and something that they can use. So that's what led to the thinking of whether we can use something in a more interactive, more intuitive learning environment, so that basically that remains in their memory. It remains with them when they leave college and they go for anything in the higher studies or undergraduate, I mean, industry jobs. So that leads to what we can do. One of the things, I mean, we do during our PhD is looking into this PhD comic page, phdcomic.com, which basically is a funny interpretation of the things that happened during PhD. And it shows here that this graduate student basically telling his faculty that this equipment was working a second ago, but it was not working when the faculty came in. And that happens. I mean, that happens to everybody, that at times something doesn't work. And then when it doesn't work, it is not that we fall. I mean, it's okay to get disheartened, but the fact is we learn from mistakes. Even when we do codings or anything, we get errors, and it is all those errors that help us to know something more in a more profound way. So we learn from doing. It's not like we just learn from reading the books. We need to learn and then use that somewhere. So, and it's okay to make mistakes, because that is how we learn more things. We learn what not to do, and that is one of the crucial things during learning age. So that's what one of the focus areas of us is, if we can create laboratories in the simulation environment, because it's not always easy to do experiments because of various reasons. So if we can create like virtual laboratories through our computers, then we can basically do the things that we read on paper in books, and then we learn from doing that. And that's one of the focus area that we want to see. And that helps in all times of education. That helps in K-12, which is the high school undergraduate education. So if we look into this learning curve here, so this orange curve is basically shows that the learning curve. So this is basically how we learn. So the learning curve is more smoother, and we learn more things if we do this learn by doing. When we do these projects, when we bring something from the book to the practical world, when we put theory to practice, and that helps in undergraduate, masters, PhD, and that helps in getting a job, because that's what industries also want to do. So now the question comes I mean, basically in terms of thinking, what do we basically need to do to do that? We all have experiments, we all have laboratories as well. The goal here is to the best way to club those laboratories and do even have like both of them in the same environment, like having classroom teaching with virtual labs, so things like that. So now where that leads to is something called computational thinking, because computational thinking is something that leads to this kind of environment where we basically learn by doing. So if you think about what computational thinking, this is from, I mean, Wikipedia, or if you look into any paper, any journal papers, that's basically what is there in terms of computational thinking. There are 4 steps to it. There is problem decomposition, algorithm, pattern recognition, abstraction, and algorithms. So I was thinking of what can be a good example to do this. So I'll just share a 2-minute story. So for example, when I came to this apartment where I'm staying in, we used to have a lot of problem with water. So essentially, water used to come every 2 hours in the morning and 2 hours in the evening, and we need to fill up a overhead pump and then use that water throughout the day. So we didn't want to waste water, so we were not running the pump for a longer time. And then what happened when we had guests over, we ran out of water. So this became a huge problem of what is an optimum time to run the pump so that we have water for all the people at the household. So I was thinking what can be done, and then I mean, a simple MATLAB script helped in terms of like if we just know how much water the tank can hold. So if we just decompose the problem, we basically have the tank, which if we know the capacity of the tank, and then we measure the flow rate of the water coming into the tank, we can just measure using a cup if we know the volume, and then a stopwatch. So once we decompose this problem into the smaller problems, and then we measure how much water we are using, we can just measure the volume of a bucket and then measure over 3-4 days average how much water we are using. So once we have all those three problems, we can just write a script and then calculate how much time we should run the pump so that we have water for all the people. And then if we have guests over, we just change the number of people, which is the one of the input conditions to the problem, and then we know how much more time we need to run the pump on. So this is a problem. Say for example, there's a problem which is a household problem, but now we are connecting that to like maths, physics, there's piping. Now we can make this more practical in terms of what is the loss in the pipes that leads to like fluid mechanics stuff problem as well. So that is how things work. So if we have a problem, instead of just panicking, if we decompose those problems into smaller problems, find out what can be a good way to mathematically express that problem and find out an algorithm. And then what helps is basically we change one condition and then we basically know what extra thing we need to do. And now this can be used for everybody in the household, for different people in the different floors of the apartment, and so that becomes easily scaling up. So that's what basically, once we have an algorithm that can be used for everybody, and it does not just solve one person's problem but everybody's problem. So that's how we can think of different steps for any problem basically. And that is not, as I mentioned, this is a household pumping problem, and that is not only for engineering problems. That's what we do if we have to go somewhere. When the lockdown gets over, if we go for a travel somewhere, if we go to visit places, then what we do is we plan out what are the things we need for, if it's a 5-day trip, what are the things we need for the 5 days, and we plan that. We learn from mistakes also. We learn from what we have done in the previous trips, and then we change accordingly. So that's how we decompose a problem, and we just think strategically instead of panicking in one given situation. And that is basically the gist of computational thinking. So you can see that this is not something that computer scientists need. That is something that every person need, every engineer and scientist need, because that's how we address any problem. And that is what we need for all different types of courses, curriculums, and that is what helps big for industries as well. Because when you go to industry, when the students go to industry, they get exposed to various other types of problem which they are not aware of. So if they know how to decompose this problem, then they can fall into club all those pieces and then go ahead for solving a problem. So if we think about that computational thinking, if this algorithmic thinking, so this is what we call coding as well in some forms. But then it's not about just coding. There's something called learn to code. That is how we run the scriptics, the syntax. But the important thing is